Lesson 4 and Lesson 5 of Algebra 1. We're going to be looking at both in this video. First of all, we're going to look at order of operations. The goal is to be able to simplify expressions using the order of operations. Extremely important to follow these orders because if we don't have consistent answers, okay? So when we look at the order of operations, a lot of times you'll hear it as PEMDAS because P for parentheses, E for exponents, M for multiply, D for divide, A for add, S for subtract. Now, multiply and divide are in the same color here because they are on the same level. Whenever we see them together in a problem, we do them at the same time, just left to right in the problem. Same with adding and subtracting. All right, same level, just do left to right once we see them in the problem. Well, in this first example for parentheses, we need to do those red parentheses first. So, in this problem, we look and do 3 times, well, we do what's in the parentheses. 4 plus 2 is 6. We're going to add 5 squared minus 10. Nothing with that yet. Then we look and say, all right, next we need to do those exponents. Well, those are the yellow exponents, so we need to do that 5 squared. So we say 3 times 6 plus 25 minus 10. All right, we got rid of our exponents. Now we need to see if we have any multiplication or division to do. And we do. We have that 3 times 6. So we simplify that to 18 plus 25 minus 10. Lastly, we see if we have any addition and subtraction. Well, we have both actually, so we need to do left to right. We do 18 plus 25. That gives us 43. We subtract 10, and we get 33. Okay? We need to do all of that work to be able to solve those order of operation problems, especially in the correct order, so we don't come out with anything inconsistent. Okay? Let's continue looking at this lesson. So order of operations is extremely important. Some other examples we have here. Let's look at just a couple of these examples. So let's first look at this bottom one here. 4 to the third plus 9 divided by 3 minus 2 times 3 squared. Well, we look and see if we have any parentheses. And we do around that 3, but there's nothing to do inside, so we kind of have to leave it there. Then we look at our exponents, and we see we have 2 of them. So I'm going to do 4 to the third first, and we get 64 plus 9 divided by 3 minus 2 times, well, 3 squared is 9. Then we look and see if we have any multiplication or division, and we do. We have both, so we go left to right. So we do 64 plus, well, 9 divided by 3 is 3. And then we subtract 9 times 2, which is 18. All right, we can now do addition subtraction, left to right. 64 plus 3 is 67 minus 18. We get a final answer of, I believe, 49. Okay, so whenever you get to those pairings of multiplication, division, addition, subtraction, just remember to go left to right and you'll be just fine. All right, let's do one other example of our PEMDAS. And let's just go, let's keep going. I'll go back to one of these. We'll do 2 times 3 minus 2, all of that squared divided by 2. This is kind of a funky one because we have to look in those parentheses, but we see that we have multiplication and division in there. Well, whenever we're inside of parentheses, we start over with PEMDAS, and multiplication would come first. So we would say that we have 6. 2 times 3 is 6, minus 2 squared, and then we're going to divide that by 2. We continue in the parentheses to say 6 minus 2 is 4 squared divided by 2. Well, we can't do the division first because we need to square first. So we get 16 divided by 2, which is 8. All right, parentheses, exponents, multiplication, division, addition, subtraction. Do it in order and you'll be just fine. Sometimes it looks pretty complicated, but if you want to or need to color code it, that's up to you. Okay, let's continue looking at these. This big long word problem that we tried in class in one of my classes, honestly, what it's just looking at is being able to do the order of operations and then subtract between the two to find the difference. Lesson 5 is also very quick and easy, finding absolute value and adding real numbers. So first off, absolute value is the distance from the number to 0, no matter if it's positive or negative. We are simply looking at how many units away from 0 is a number. So absolute value of 4. Remember that we see absolute value with two lines like this. Oops, sorry, that bottom line shouldn't be there. Okay, absolute value of 4. We would say, well, 4 is 4 units away from 0. But the absolute value of negative 4 is also 4 units away from 0. Since we're talking about distance, we can't have a negative absolute value. We can't be a negative distance from 0. We can only be a positive distance. That doesn't mean that an absolute value problem won't ever come out negative, because if we look at an example like this, okay, negative 11 minus 2, that negative sign is outside of the absolute value. First, we must do the absolute value. So absolute value of 11 minus 2, that's really just the absolute value of 9. And then we take the absolute value and say, well, that's just, that minus sign stays out, and that's 9 as our absolute value. So truly, we just have an answer of negative 9. All right, so these absolute values can sometimes cause us to have a final answer of a negative number if there is a negative sign outside of the absolute value, or if we're doing a subtraction problem, something like that. Another example of this is, let's say we have the absolute value of 9 minus the absolute value of 19. How about? Well, if we do each of these, absolute value of 9 is just 9. We have to do the absolute values first, so absolute value of 19 is 19, and we subtract them. Since that subtraction sign is outside of those absolute value signs, we do get an answer of negative 10. All right? Even though absolute values themselves can't be negative, if we're looking at an expression that might have a negative sign on the outside or a subtraction, then we could end up with an answer being negative. All right, so absolute values, the distance away from 0. Okay, the other part of this lesson is being able to add integers. I'm just going to really quickly think about some different ways to do this with you. First, adding integers with the same sign. We can add the two numbers, like 2 and 7, to get 9, and then we keep the sign. So we would say 9 is not just a positive 9. Since these are both negative 2 and negative 7, we actually get a negative 9. Well, with 3 and 10, we can add those up and get 13. And since both of them are positive, we truly get a positive 13. But oftentimes we don't have the same sign. So we need to deal with ones that have different signs. And our little key here is, if we subtract the two numbers and keep the sign of the number with that greater absolute value, we can use this as well. So let's try it with this negative 5 plus 9. We can take 9 and subtract 5, so we get 4. And then we need to look at which one has a bigger absolute value. Well, the absolute value of negative 5 is 5. The absolute value of 9 is 9. So 9 has the bigger absolute value, so we keep a positive sign with our 4. With our 3 plus negative 8, we can say 8 minus 3 is 5, but which one has the bigger absolute value? Well, the absolute value of 3 is 3, and the absolute value of negative 8 is 8. So that negative 8 has a greater absolute value, so we keep the negative sign. Okay, this is one way to think about adding integers. All right, same sign, we add and keep the sign. Different signs we subtract and keep the sign of the greater absolute value. Another way to think about this is winning and losing. So maybe you're playing a game that collects points. You lose 7 points, but in another round you win 9 points. Well, you would have an overall winning of 2 points. Okay, so winning and losing points. If you lose 4 points in one round and then lose another 2 points in another round, we would have a total of losing 6 points. Winning 5 and losing 3, we have a total of 2 points. Okay, so winning and losing points is a great way to think about it as well. Lastly, you could think about a number line. So let's say we go back to this 5 and negative 3. This one right here. We can think about a number line, okay? From 0, 1, 2, 3, 4, and 5. And down to down negative sides as well. So we could say, all right, well, from 0, I'm going to go up 5 because I won 5. So 1, 2, 3, 4, and 5. But then I have to go back 3 because I have negative 3. So I'm going to go from this 5 and go back 1, back 2, back 3. And of course, this lands at 2. So a number line is another way to think about our integers and being able to add them, whether they have the same sign or different signs. All right. So let's see. Let's just do a couple of these. If we're looking at the absolute value of negative 9.3, we would end up with just 9.3, since that's 9.3 units away from 0. This next one, though, if we have negative absolute value 45, we take the absolute value first and get a negative 45. All right. Do the absolute value signs first and then take that negative. But on the next one, we see that there's an operation inside of the absolute value. So we do that first and say 14 plus a negative 22. Well, that gives us a negative 8. Okay? Remember, different signs we can subtract and keep the sign of the greater absolute value. Well, the absolute value of negative 8 is just 8. And lastly, I'll do this negative absolute value of 7 minus 16. We need to do the 7 minus 16 first, so we get a negative 9. Well, the absolute value of negative 9 is just 9. We need to keep that outside subtraction or negative sign, so we say that this is just negative 9, okay? Because the absolute value of negative 9 is 9, but we have to keep this negative sign, okay? So absolute values, adding integers, very much related to be able to get the correct answer. This was lesson 4 and 5 of Algebra 1. Hopefully it's helpful for your homework and for studying.